Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 4 of the lesson on arithmetic sequences, and in this video I'll be looking at how to find the first term and the common difference of an arithmetic sequence if you know two sums. So here we have the sum of the first 10 terms of an arithmetic series is 120. The sum of the first 20 terms is 840. And we're being asked to find the first term and the common difference of this arithmetic series. Just a brief aside, why is it being called an arithmetic series rather than an arithmetic sequence? A series is when you have a sequence of numbers that you sum, that you add up. So that's the language being used here. Now because it's a sum, we need to use the sum formula, which is sum to n is n over 2 multiplied by 2a plus n minus 1d. And students always say to me, is this in the formula book? The answer is yes it is, however I strongly recommend that you learn it because then you become fluent in its use. So, first of all then, we have the sum of the first 10 terms is 120. So we're told that the sum to 10 is 120. So what I'm going to do is I'm going to substitute 10 for n in this sequence here. So n over 2, I'm going to write 10 over 2, and in the bracket 2a plus, now n is 10, so 10 minus 1 would be 9, so I'm going to write 9d equals 120. 10 over 2 is 5, so 5 lots of 2a plus 9d equals 120. Now what I could do at this stage is to expand this bracket out, but I'm not going to do that. I can actually get a simpler equation by dividing both sides of the equation by 5, which gives me 2a plus 9d equals 24. So I knew that the sum of the first 10 terms is 120, so I replaced n with 10 in both places in this formula for the sum, and I now have an equation in terms of a and d, which are the two things I'm trying to find out. I'm also told that the sum of the first 20 terms is 840. So on this side of the board here I'll just write sum to 20 is 840. And I'm just going to do the exact same process. I'm going to use the sum to n formula, but this time instead of using n is 10, I'm going to use n is 20. So I have 20 over 2, and then in brackets 2a plus n minus 1. Let's just correct that, because we know that n is 20, so 20 minus 1 would be 19. So 19d, and that equals 840. 20 over 2 is 10, so I have 10 lots of 2a plus 19d equals 840. And just as I did here, where rather than expanding the bracket out I divided by the 5, here I'm going to divide by the 10, which is going to give me 2a plus 19d equals 84. So what I have now is two equations in terms of a and d, which are the equations, which are the unknowns that I'm trying to find out. And that should make sense to you, it should be familiar at this stage. You think, okay, I've got two unknowns, I must be looking to form two simultaneous equations that I can solve to find those out. So, 2a plus 19d equals 84, this equation here. And the other equation, 2a plus 9d equals 24. I can subtract the whole of the second equation from the whole of the first equation. 2a take away 2a is nothing, so it eliminates a. 19d take away 9d is 10d. And 84 take 24 is 60. So 10d is 60, which means that d, the common difference, is 6. Now that I know d, I need to work out a. So I found the common difference, I need to find the first term. So I can substitute d equals 6 back into either one of these equations. So I'll choose the second equation here. So 2a plus 9 lots of 6 equals 24. So 2a plus 54 is 24, which means that 2a is negative 30. And that a is negative 15. So what I have here is a is negative 15 as my first term, and d equals 6 as my common difference. What I could do if I wanted to, I could write out the first 10 terms and show that the sum is 120, but I'm quite confident in my approaching process here that that's worked. So there we go, job done. Thank you.